Dear students, we are going to see 4.1 and 4.2 in this video. You see the definition. A curve is smooth if it has a parameterization x is equal to f of t, y is equal to g of t on an interval I such that the derivatives f dash and g dash are continuous and not simultaneously zero except possibly at endpoints. A curve is piecewise smooth if the interval I can be partitioned into closed subintervals where C is smooth on each subinterval. Note, a smooth curve will have no corners or cusps. You see here, what is contour? A contour gamma is either a single point z0 or a finite sequence of directed smooth curves such as gamma 1, gamma 2, etc. gamma n. Actually, uh, a contour is nothing but capital gamma, denoted by capital gamma. This may be a single point z0 or maybe a smooth directed curve gamma 1. Sometimes a contour capital gamma is nothing but gamma 1, gamma 2, etc. gamma n. That's why we are writing the contour is nothing but summation of this gamma 1, gamma 2, etc. gamma n. Okay. Now we see parameterization. Suppose a contour is nothing but from z is equal to z1 to z equal to z2 along a straight line. Then how to write z of t? That is equal to z1 plus t times z2 minus z1, where t is 0 less than or equal to t less than or equal to 1. T varies from 0 to 1. Now suppose our contour is a circle which has center z0 and radius r. Then how to write the parameterization of this circle? That is z of t is equal to z0 plus r e to the power it. Here z0 is the center and r is the radius. Now you see here this circle is traversed once counterclockwise. Counterclockwise means like this. Then we have to write z of t is equal to z0 plus r e power it. This is opposite direction of the regular clock, that is counterclockwise. Okay. Suppose a circle traversed once clockwise, then what is z of t? Here a small change is that you have to change in the exponential part here positive to negative, that is z of t is equal to z0 plus r e to the power minus it. Here z0 is the center and r is the radius of the circle. Okay. Now how to evaluate the contour? That is, if f is continuous on a smooth curve C given by z of t is equal to x of t plus I y of t, a less than or equal to less than or equal to b, then how to evaluate this function f over this contour C, which means is equal to integral a to b. You have to write the function in parameterization form, then find the derivative of that z of t, multiply here and then integrate with respect to t. We will see few examples on this, how to evaluate the contour integral. Now see the first question. Find integral over gamma z square dz. Here our contour is gamma is denoted by gamma, is defined as along the directed line segment from 0 to 2 plus I. That is our gamma. Okay. Now here from the given we can write what is f of z. From the given integral we can write what is f of z, that is z square. F of z is equal to this one, z square. Okay. Now from the question we can see our directed line segment starts from where? That starts from 0. So now starting point you give the name as z1. So z1 is 0. z2 is 2 plus I. Okay. So now we have written f of z from the given question and we have given the names For the starting point z1 0, for the ending point 2 plus I z2. Okay. Now you see here how to write the parameterization of the given function. This is the rule. Okay, just we apply the rule. So that z of t is equal to, what is z1? Z1 is here 0. So 0 plus t times, that is the rule, t times z2 minus z1. That is z2 is 2 plus I minus z1 is 0. So that what you will get z of t, that is t times 2 plus I. Okay. Then what is the limit for t? Always limit for t is 0 to 1. Okay. And f of z is equal to z square. Okay. So here we have to find, see, to find the integration, we have to find the given function in terms of t, then find the derivative, then integrate with respect to t. Okay. Now here f of z is equal to z square, which is given in the question. Now what is z of t? See here, z of t is t times 2 plus I. You substitute here. So that z squared is equal to t times 2 plus I whole square, which means t squared multiplied 2 plus I whole square. Okay, this is called f of z of t, which we need to substitute in the integration. Okay. Next, what is z dash of t? Okay, see here, after finding this one, you have to be very alert how to find z dash of t. Maybe some students by mistake they will calculate from this z dash. No, from here, from z of t you find z dash of t. Okay, which means you differentiate with respect to t, this one. So now z dash of t is equal to, you see here derivative of t is 1 multiply 2 plus I is nothing but constant, so that 2 plus I. So z dash of t is nothing but 2 plus I. Okay, now we know the rule. Integral over c f of the dz, this is the given. So we have to find this one by using our derived values. So now you see here, take this rule. Now this is given, integral over gamma z squared dz. Okay, this is equal to integral, we know that the limit for t is 0 to 1. Then you write, what is this, f of z of t, which means f of z of t is t squared 2 plus I whole squared. So I write here t squared 2 plus I whole squared. Multiply here, what is in the rule, z dash of t. So that what we have calculated z dash of t, that is 2 plus I. So write it here. So we substitute everything into dt, integrate with respect to t. Now here 2 plus I square is constant, 2 plus I is also a constant, you take it out of the integration. So 2 plus I whole cube, integral 0 to 1 t squared dt. Integration t squared is nothing but t cube over 3. Here limit 0 to 1. So that here 2 plus I whole cube, here substitute the limit for t, upper limit is 1, lower limit is 0. That's why you will get 1 by 3 minus 0. Now you expand this 2 plus I whole cube by using this rule, a plus b whole cube, a cube plus 3a squared b plus 3ab squared plus b cube. So that you will get 8 plus 12I minus 6 minus I into, means multiply 1 over 3. So that your final answer is nothing but 2 over 3 plus I 11 over 3. This is in the form of a plus ba. Okay, that's it. Now we'll see the another question. Now find integral over gamma z bar minus real part of z dz along the directed line segment minus 3i to 3 plus 2i. Okay, now you see here, take what is f of z from the question, that is z bar minus real part of z. Okay, we are writing from the question. Now in the question, what is given, the starting point, that is minus 3i, which means z1, you take z1, that is the starting point, minus 3i. What is z2? That is 3 plus 2i, that is z2. Okay, now after that, to write the parameterization, you consider this rule. Okay, now z of t is equal to z1 plus t times z2 minus z1. So now z of t is equal to, z1 is minus 3i plus t times, what is z2, 3 plus 2i. Then Z1 is minus 3i. Already we have one minus in the rule. Therefore, here it will come plus. So that's why I write plus. Okay, so plus 3i. Then you write Z of t is equal to minus 3i t times say 3 plus 5i. Now here you separate real part and imaginary part. So here this is only one real part, that is 3t plus I, here 5t minus 3, because here 5ti, so I take as a common factor, so 5t, here minus 3i, the imaginary part, so here minus 3. So that this is your z of t. Okay, we have calculated what is z of t. Then next what we have to do, see in the given function f of z, what we have to do, substitute our value. Means what is here, z of t is 3t plus I 5t minus 3, but what I want here is z bar, which means you take the conjugate of this, so that 3t, here you change the sign, that's why I am changing here minus. Okay, because I want z bar, so 3t minus I 5t minus 3. Okay, then minus real part of z. Okay, minus, here real part is 3t, so put 3t minus 3t. Okay, then here minus 3t plus 3t will be cancelled, so the remaining is you multiply the minus inside, so minus and minus plus I, and then plus 3i minus 5it. This is your f of z of t. Okay, after this we have to find z dash. How to find z dash? You have to find z dash from this one. Okay, from this one. Okay, now z dash means you do the derivative with respect to t here, so 3 into 1, so 3. Now here this will be 5 into 1, 5i, so 5i. This is the constant. If you take the derivative, it will be 0, so that z dash is nothing but 3 plus 5i. Okay, now what we have completed, we found f of z, we have calculated z dash of t, we know the limit always, what is the limit for t, 0 to 1, so that now we can substitute in this rule. Okay, what is that? Actually this rule is not required here. Okay, so now integral over c f of z dz. Okay, the question, integral over gamma z bar minus real part of z dz. Okay, now this is left side. Now integral a to b, here limit is 0 to 1 for t, so 0 to 1. Now what is f of z of t? That is here f of z of t, that is 3i minus 5it, so 3i minus 5it. Okay, now what is here is the dash of t, is the dash 3 plus 5i, that is 3 plus 5i into t dt. So now here 3 plus 5 is a constant, so you take it outside. Now here I is common, so I is also you take out of the integration. So now what is the remaining? 3 minus 5t dt. Then you do the integration, 3t minus 5t squared by 2, limit is 0 to 1. So now here 3, see 3 plus 5i multiply I outside, so you multiply I, so 3i, here I into I squared, so minus 1, so minus 5, so that 3i minus 5, here substitute the upper limit minus lower limit, so 1, so 3 minus 5 by 2, so 3 minus 5 by 2, so 3a minus 5, here 3 minus 5 by 2 is nothing but 1 over 2, so you multiply inside, so you will get minus 5 over 2 plus I3 over 2, this is nothing but the value of the given integration. Okay, now we will see the continuation in the next video.